Good morning, class.
Good morning.
Today we're doing geometry. We are actually going to be doing a practical lesson. And for this particular lesson, all you need to do as a teacher is to have cut some circles like the one I am having. You can see they're different sizes. You can see they're different colors. They are different sizes again. And for this particular exercise, that's exactly what you need. So as a teacher, what you can do at home, you can use your side plates. You can use your very big plate so that you can have a big circle. Or you can use any round object. Now round as opposed to circular, just be very careful that it is round. So now you bring these into class, and mind you, if you're having 30 students, it would mean you have cut 30 of these round things, but just make sure they are not the same, because if they are the same, then the learners cannot get the gist of your lesson. So when they are not the same, you cut them. What to do, you just cut one and then you put it on top of many other papers and you use your pair of scissors, then you will have 6 at a time. 6 by 5, you're getting 30 of them. That should be an easy exercise. So all you need are these kinds of discs for this particular lesson. Now I'll use only one disc right now, and we are going to start off by justifying why this shape is called a circle. Why do you call this a circle? You need to ask your learners. They need to tell you why this, if they say, for example, because it is round. Now, round is not a maths concept. For it to be a circle, it has to have some certain features. And the first one is the one that I want you to find. I want you to find a circle, a center of this particular circle. Let's see how you give your learners this disc, and they must go through an exercise of finding the center of the circle and observe what they do. Some of them will take some pens and try and mark a center somewhere where they think it is, but those who really are thinking mathematically, they will do some foldings, like the folding that I am doing now, which must be very exact. They will fold through, and if you have folded once, definitely you're not going to get a center. You have to fold another fold like I am doing, and I want to believe that perhaps after 1 or 2, you will now get to what we call a center, which will be the intersection of all those folds that you have made. I have now found mine. I folded twice. I could fold 3 times. I could fold as many times as I want. But me and you know that if it has to be a center, definitely it will always be at one point. And what I'm going to do now, I'm just going to put a small mark at my center, because this is basically what I'm going to use in this exercise. But before you get that, get your learners with the terminology of geometry. What makes it a circle? What do we call this part around here? Your learners should be able to come up with the word circumference. And when they come with that word, so for registration, you put that word on the chalkboard and you leave it there. But now, not only that, they need to explain what is a circumference, right? It is the surrounding around each circle, right? Now that we have a center, what's a center? It's a point that is equidistant from the circumference. You heard me saying equidistant. What does that mean? Equal distance from the center to any part of the circumference, all right? And those folds, you can see them now. Here is one of them, from the center to the circumference. And in mathematics, there is a particular name that we give to this kind of a line. What do we call it? Your learners would find that particular name, because remember, they learn circles as early as preschool. Some of them, they read these things in papers. Some of them, they observe them on TV. So the second word that you will write is radius, which is the distance between the center and the circumference of the circle. Now, don't leave it there. Make sure that the learners know that the distance between the center and any part of the circumference is called a radius. And it's not only one radius. How many radii, by the way, do we have in a circle? Allow them to guess how many. Some of them, looking at your folds, the folds that you've made, they may count and say 1, 2, 3, 4, 5, 6 radii. Do not leave that out up until you get to a stage where they understand there are many radii. What you can do is to continue folding and creating other lines other than those that they've counted. Somebody should, from the learners, come with the acknowledgement that there is an infinite number of radii in each circle. So you have got 3 words now. You had circumference, you had radius, now you have radii, when they are many and an infinite number for that matter. They are not countable, okay? Now from radius, you move, you've got a radius this side, from the center to the circumference. You've got a radius from the center to the circumference. But now, it's a continuous line that goes through the center of the circle. And in geometry, we have a specific name, you know that. What name do we have for that? We will be having diameter. And start from there to tell them di in mathematics refers to 2. In this case, it refers to 2 radii. And you put the name on the chalkboard, diameter. Don't just put the name there. Explain to your learners what a diameter is. How different is this line that goes through the center of the circle from one part of the circumference to the other part of the circumference? That particular line, how many are we going to have also? We had an infinite number of radii. So how many diameters are we supposed to be having now? They will also be infinite. They are uncountable. Remember, a circle is a special shape that is used in our African nature. If you remember, all of us as Africans, except the born frees, we were born in rondaverse. Why? Because for a circle, it allows you to occupy more space. There is more space that you can have as a circle. Remember, in the olden days, tell your learners these stories. They will love them. Tell them that in the olden days, that rondaverse would have been a kitchen, where that center would have been the fireplace, okay? And somewhere in the room up there, you would be having your kitchen somewhere there. And in the same room, you would be having a bedroom. In the same room is also a lounge. But what is important in African nature is that kind of situation, even though it was so much signifying impoverishment, that kind of situation, it used to unite us as a family. Because around that fire in that center, that's where we were learning of the stories. That's where we saw our dad respecting our mom respecting, and so forth. Back to the lesson. Now we have the diameter, we have the radius, we have the circumference. That is the notion around there. Those are not the only things that we have in a circle. Now starts the action. I now want you to instruct your learners to fold any part of the circumference to the center of the circle. Remember, you asked them to create a circle. Sorry, to find a center, right? Now you ask them to fold any part of the circumference to the center. They will now end up with such a shape, okay? Now, you then do another folding. You see there's a corner there where you folded. From that corner now, not anywhere, remember? From that corner now, you make another fold to the center. and you should end up with something like this. That's a second fold that you are making. By the way, your learners should know now what kind of lines are these that are formed when you do these foldings. Remember, we spoke about the diameter, we spoke about the radius, we spoke about the circumference, but now we've got a different line that has got nothing to do with the center, all right? What do we call this particular line? This line is now called a chord, C-H-O-R-D. You write that on the chalkboard so that the learners can register. And you also define it. What is that line? That is a line that moves from any part of the circumference joining to the other part of the circumference. It doesn't necessarily need to pass through the center. Okay? Because if it passes through the center, we then give it another name. What's this name now? We say it is a diameter. So a diameter is a form, is some kind of a chord. It's just that it passes through the center, so we call it diameter for passing there. All right. I hope your learners will understand that. This fold that you're going to make is from these corners that have been formed. You are also folding this to the center, and if you are accurate with the other folds, this will kind of fold straight to the center automatically, and it will give you the third chord, right? Now, when you are finished with that, do you see the structure that you have now? I hope your learners will be so happy, because every learner will know what is the name of this particular figure now. This figure is called a triangle. Why do we call it triangle? It has got 3 angles, and make sure that your learners can see the difference between the lines in a triangle and the angles, which is the space between the lines, the space between the lines. How do we define a triangle? Saying a triangle is a 3-sided figure is not enough. Remember, if I can write here, draw a line like that, and draw another line like that, draw another line like that, that's 3-sided figure. But look at it, it is 1, and then 2, and then 3. That's a Z actually, or if you flip it, that's an N. It's not a triangle. So how do you have to define a triangle? Make sure that you say 3 lines enclosed. So it's a figure that joins 3 lines that close together. 1, 2, 3. And what type of a triangle is this? That's another lesson. Don't teach all these in one day, because the types of triangles, you can start with the same circle that we started with, and you come to the types of triangles. You tell them to find out whether this side has got a relationship with this side and that side. In which case, if these sides are equal, then you can say it's an equilateral triangle. But if you're teaching equilateral triangles on that day, that's a lesson on its own, because there's a lot that learners need to know about equilateral triangles. There's isosceles triangles, there's scalene triangles, there are triangles defined according to their lines, there are triangles defined according to their angles. There are many sorts of triangles. I said that's a lesson for another day. So do not congest your lesson when you're teaching the learners. Make sure that you focus on the aim of that particular day. So to carry on with this exercise now, I want you to find the midpoints of each side of those triangles. Now, what is a midpoint? In English, it's a point in the middle. Midpoint. Point in the middle. So how do you find the middle? Let your learners fumble, let your learners play, But I think your learners would be able to just make a fold like I am making here and find a midpoint. Okay? Now I want you to find that midpoint and to mark it. All right? First midpoint, you find the other midpoint, you do that by folding again. Find the other midpoint. Okay? You mark it, and lastly, find the last midpoint. Ensure that you are accurate. Otherwise, if you are not accurate, the figures that you want to find to form here, they will not be formed. Now you found your midpoints. That is your points in the middle of each of the sides. Now I want you to fold the first corner to that first midpoint. Let's see what happens. Here am I doing the folding. Each time you fold, you then straighten up. Now, you've got another figure now. What figure is this? Ask your learners. Let your learners ramble around. What is this particular figure now? It's still having 1, 2, 3, 4 sides. So it's no more a triangle. It should be some form of a quadrilateral. Remember, each time you introduce a name, write it on the chalkboard and explain what the name is about. If you're saying quadrilateral, for example, don't assume that your learners have heard about this name and they know it. Explain it. Take the learners into a journey of mathematical language. When we say quad, the maze quadrangle. When we say quad in mathematics, we mean 4. 1, 2, 3, 4. Refer them to quadruplets. When a mother has got 4 babies at the same time, we call them quadruplets. There's quad 4. 1, 2, 3, 4. All right? But now there are many of such shapes that have 4 sides. But this particular one has got some features that make it to be critically known as a particular figure. And what are those? Let's look at it. It's like this. You can turn it around, and perhaps it looks much better when you put it like this. Let your learners fumble around until they come with the word trapezium. And you write that word on the chalkboard. Why? Because you are going to discuss and talk about the properties of a trapezium. What makes it a trapezium? What does a trapezium have that the other figures don't have? Let's inspect this particular one. It has got a line that's shorter, a line that's longer, 2 lines that look alike. Is this the only type of a trapezium? I'm not sure, but I can show you just by doing this that this particular one also is another type of a trapezium. But what is a trapezium? A trapezium should be having a set of parallel lines, just one set. Even if it's like this, as long as it still has a pair of parallel lines, this line and that line, that we call a trapezium. It doesn't have to be like this, it can stand like this. Do these variations in your class so that your learners don't just know one kind of a figure. They must know the properties, but they must be free to jungle around and know that it is still the same figure when you push it upside down like that. Now that it's a trapezium, is that the only feature that makes this a trapezium? Perhaps yes. One pair of parallel lines that makes it a trapezium. I want us now to do the last bit of this exercise, and I want us to fold the other corners. We fold them to the other corner like that, and you will have a figure that looks like this. And what do we call this figure? Perhaps if we do it like this, I heard you saying rhombus. I'm not sure, I don't know. Maybe it's a rhombus if it is like this. Maybe it's a rhombus if it is like this. Is it a kite? Or is it a rhombus? Get into an argument where your learners will learn and know what a rhombus looks like. A rhombus must have all sides equal. How do we test that the sides are equal? We can flip this thing like that. If it lies exactly on top of each other, which you can use that exercise for one other day where you talk about congruency. But now you're not doing that, remember? And don't wobble around when you're doing your lessons so that your learners don't get confused. You call it a rhombus. Get into the features of a rhombus. What does it look like? What is a rhombus? What is not a rhombus? When does it become a rhombus? Is it a kite? Is a kite a rhombus? Is a rhombus a kite? Are they related? Don't push your learners and you can deviate and go back also to another figure that they know from preschool, square and rectangle. Which is which? Is a rectangle a square? Is a square a rectangle? Get into that argument and allow your learners to argue about these things, because the rhombus is some form of a kite. Why? Get into a definition of a kite. A kite must have two adjacent. Once we say adjacent, now that's a mathematical word. Put it on the chalkboard and explain it. What does adjacent mean? It means next to. All right? There are two words that we use when we're talking in maths. We say opposite, that means you are that side. And we say adjacent, that means you are next to. So this, for the kite, you need two sides that are equal, but they must be next to each other. These others, they can also be equal, right? But now, they can be longer than those. But they can also be equal as they were equal with that. So my question is, and the question that you need to let your learners debate about, is a kite a rhombus? Or is a rhombus a kite? What makes each one of them to be what it is? All right? Now, you can see with this kind of exercise where you moved from a circle, you have now covered, and you can see something very beautiful. After the folding, the folds are still left like that. You can now ask your learners to do this exercise again at home and try and find as many other figures and names that they can attach to and see if they can develop their knowledge of geometric concepts. And keep this thing, because you're not going to be cutting circles every day each time you want to do a lesson. You can move one other time, not necessarily from a circle, but you can move from a rectangle and construct many other things. And do this at any level for introduction, but make sure that your lesson doesn't overlap with others. You're not talking about triangles, and then you talk about rhombus, and then you talk about many other things, except that you just want them to know the names of the figures. That will be the end of our lesson today.